All right, let's get right into it. For as long as we've had factories, we've had alarm bells. You know, those loud, jarring signals that tell you something's already gone horribly wrong. But what if we could get rid of those alarms forever? Today, we're talking about how AI is making that happen and how it's taking manufacturing from a reactive, break-fix world to a future of, well, self-fixing factories. Seriously, just let that sink in for a second. This isn't some far-off sci-fi concept anymore. We're talking about a production line that doesn't just grind to a halt when something breaks. Instead, it sees that failure coming days, maybe even weeks in advance, and literally adjusts itself so it never even happens. That's the huge shift we're unpacking right now. And this really just lays it all out, doesn't it? On one side, you've got the old way of doing things. The alarm goes off, production stops, money starts draining away, and it's all hands on deck to fix it. But on the other side, that's the new world. AI acts like a crystal ball. It lets you see the problem coming so you can act before it's a crisis. We're talking planned, calm maintenance, and a factory that just keeps running smoothly. So, how do we get this crystal ball? Well, it all starts with teaching our systems how to see. And I don't mean with cameras. I mean with data. This is where AI basically becomes this new kind of super inspector, one that can spot tiny little flaws that are completely invisible to any human. The first tool in our AI toolbox is something called supervised learning. And the analogy here is perfect. It's like you're training the AI with flashcards. You show it thousands and thousands of examples. See this sensor data? That's normal. See this weird reading? That means a bearing is about to fail. You do that enough times, and pretty soon, the AI gets incredibly good at recognizing all the known problems. And these are the names of some of those AI inspectors. They're not just theories. These are powerful models that act like tireless experts on the factory floor. Their whole job is to spot the usual suspects, all those common faults that we've seen happen over and over again in the past. And they are very good at it. Okay, but what about the problems you've never, ever seen before? The ones that come out of left field? Well, for that, we need to bring in the detectives. And that's deep learning. This is a whole different ballgame. You don't give it flashcards. You just dump a massive pile of raw data on it and say, go find something weird. It's like a detective exploring a new city with no map, just looking for patterns and strange connections nobody else has spotted. So these AI detectives, their superpower is knowing what normal looks like so well that they can instantly spot when something is even a tiny bit off. They are amazing at flagging those totally new, never-before-seen issues, what we sometimes call the unknown unknowns. And those are usually the ones that cause the biggest disasters. So our AI can find problems now, both the old ones and the new ones. That's a huge step. But the real game changer, the thing that changes everything, isn't just seeing what's wrong now. It's foreseeing what's about to go wrong. Right. This is the massive jump from detection to what we call prognostics. It's really the difference between your smoke alarm going off when your kitchen is already full of smoke versus your smart home telling you, hey, the wiring in your toaster looks a little sketchy, you might want to replace it next week. See the difference? One is reacting to a crisis, the other is avoiding it entirely. And this timeline just shows you exactly how powerful that is. Weeks before anything breaks, the AI starts picking up on these super subtle signals. A tiny rise in temperature, a little extra vibration, things a person would never notice. Then, as it gets closer, it can give you a really precise forecast. Like, there's a 95% chance this part fails in the next 72 hours. And boom, you have this perfect window to schedule maintenance with no drama, no downtime. The crisis just never even happens. Okay, so predicting the future is amazing. But what if the AI can not only predict the problem, but then solve it all by itself? This is where it gets really interesting. This is the final step where we close the loop and the factory actually starts to manage itself. The secret ingredient here is something called a digital twin. The best way to think of it is as a perfect, ultra-realistic video game version of your real factory. It's a completely safe virtual playground where the AI can try out thousands of different fixes for a problem without ever risking the actual multi-million-dollar machinery. And here's how that loop works, plain and simple. Step 1, the AI forecasts an issue. Let's say a part is starting to run too hot. Step 2, it runs thousands of different scenarios in that digital twin to find the absolute best solution, maybe slowing the machine by 2% or increasing coolant flow by 5%. And then, step 3. Once it finds the perfect fix, an AI controller automatically makes that change on the real machine. Forecast, simulate, act. The factory literally just fixed itself.
I know. This all sounds like something out of a movie. But this isn't theory, it's happening right now. And the results are real, they are measurable, and honestly, they're pretty incredible. Let's actually look at the numbers.
Because, look, the idea of a self-fixing factory is cool. But at the end of the day, it's the hard data that proves this isn't just a gimmick. The numbers are what tell the real story here. First up, let's talk about output. In one real-world case, putting this kind of system in place boosted throughput by nearly 23%. Think about that. That's like getting almost a quarter more product out the door, using the exact same machines. That's huge. The system also gets way faster on its feet. A 39% drop in response latency means the factory can react and adapt to changes almost instantly. It becomes so much more agile and efficient. And it's not just about being faster or making more stuff. It's about doing it smarter. These optimized systems cut energy use by almost 16%. That is a massive win for the company's bottom line, and, of course, a big win for the environment. Now look at this. When we zoom in on just one area, smart machining, the numbers are just wild. They were able to remove material 50% faster. They made their tools last over 14% longer, and they cut the total time it took to make a part by 20%. These aren't small tweaks. This is a total revolution in performance. So, okay, the tech is amazing, the results speak for themselves. But let's be real, you can't just flip a switch and have a self-fixing factory. Getting this to work on an actual factory floor with real people, well, that comes with its own set of challenges. And here are the three big ones. First, there's trust. You have a machine operator who's been doing this job for 20 years. How do you get them to trust a black box? The answer is explainable AI, tools that actually show the operator why the AI is making a certain recommendation. Second, what about those super rare failures? You solve that by generating synthetic data to teach the AI what those freak accidents might look like. And finally, you've got to keep the AI up to date. You do that with regular retraining to make sure its knowledge doesn't get stale. So here's the bottom line. What we're really seeing is one of the biggest changes in the history of manufacturing. We are moving away from just simple automation, robots doing repetitive tasks, and we're building truly intelligent ecosystems, systems that can sense, think, predict, and act, all on their own. And that leaves us with one last, pretty big question to think about. This technology offers these incredible benefits. It's more efficient, it's safer, it's more sustainable, but it demands a whole new level of trust in autonomous systems. So as our factories get smarter and smarter, the real question we have to ask ourselves is, are we ready to let the machines take the wheel?